Good morning to everyone. Uh, in the previous class, we were discussing about some of the problems. Uh, the problems are related to the sewage, quantity of sewage calculation in combined systems as well as separate system, how we have to calculate it. That also we have discussed. And we have discussed um, how exactly we have to calculate the stormwater uh, if different type of cover area is given. That also we have discussed. Now we'll design of sewers also we have did. In that we have discussed the um, Shields equation to calculate the velocity, and we solved one or two problems also. Um, we have discussed some of the empirical formulas related um, to the sewer running full or partially full. Then we have discussed the Hazens-Williams formula. It has its own importance in distribution networks also. We have discussed this some of the empirical formulas um, which are related when it is partially flowing half, or it is 20% or 30% or 40%. So then we have to use this kind of formulas. So this is a problem related to the dry weather flow as well as the wet weather flow. That also we have discussed. Now we'll start with one more type of problem. It is a very simple problem. We have to use the Manning's formula to calculate the velocity here. So we'll go ahead with this problem. So then, so they determine um, the size of an outfall sewer. So what he is asking is that size of an outfall sewer. So that we have to determine it. Size means you can say it is a diameter. So intended to carry the sewage flow of, they have given sewage flow of 650 liters per second. It's very important. This we have to convert into meter cube per second. That we'll see later. So if the average slope of a line is 1 in 1000, I already said that you have two slopes. One is bed slope and one more is side slope. So actually this we will discuss in only the trapezoidal sections, but still many of you will confuse that whether it is a side slope or bed slope. Whatever it is there, it is now it's a bed slope, and the sewer is flowing half full. Half means it, you can say it is 50%, means 50% it is flowing, means half of the diameter it is flowing. Then assume n, that is Manning's n, take 0.015. So then here they have asked us to calculate the diameter. We have to calculate that. Then after that we have to use the Manning's formula to calculate the velocity. So now move on to the Manning's formula. So now apply this. So we have V is equal to, that is 1 by n. This is not in that problem he has taken as small n, but both are same. You can see, you can take it as a small n is equal to capital N here. So then r to the power 2 by 3, s to the power half. That formula you have to apply. So then if you apply that, so it is, this is the n value. Then r, this is r is nothing but a by p. So A is, of course, when you say it is a area, it is uh, area of whatever, what you can say, area of the circular section, but it is flowing 50%. Okay. So when that is there, so RA is equal to 5, area of the section is 5d square by 4, but perimeter is 5d or 2 pi r. But it is saying that it is flowing half. So means 50% of this you have to take, means divided by 2, and perimeter also divided by 2. If you make that and if you simplify it, you will get d by 4 to the power 2 by 3, means you will get d by 4 here. Very simple. So 5 get cancelled. So then you have dd is 1d will go, 1d will go. Then of course it is nothing but 50%. This will also go. Then ultimately you will get finally d by 4. So then wherever r is there, r is equal to d by 4. Then we are substituting that value here. Then yes, they have already given, yes, that is slope 1 in 1000. Then so we got this v in terms of d. So v in terms of d. Then we have the continuity equation. It is nothing but q is equal to av. Q is equal to av. So if you apply that, so of course q they have already given, that is 650 liters per second. So q already they have given, q is equal to 650 liters per second. So then 650 divided by 1000, so it will give 650 meter cube per second, because we have 1 meter cube is equal to 1000 liters. So then we'll get this value. Then area, of course 5d square by 4. Why they have taken 8 here is that it is flowing. It's very important. Many students will go wrong here. This one, this section, they have written that it is 5d square by 4, but it is 50%, means divided by 2. So when it will go up, it will be 5d square by 8. So then velocity, of course it is that we got it from here. So then we got, if you simplify it, you will get d is equal to 1.3. So this is how you have to calculate the problem. Directly you won't give, indirectly you have to calculate it. So here what you have to remember is that sometimes he will give the velocity, then he may ask you to calculate the q. Sometimes q will be given, they may ask to calculate the velocity. That is how we have to make it. So then this problem we will solve it in the next class. Thank you.